So we're going to look at the magnitude of a vector given in ai plus bj form. So the magnitude of a vector is talking about its length. So if I had here an initial point P, which let's say was x1 comma y1, and a terminal point on my vector Q, which was say x2 comma y2, then I want to find the length of that vector. And so finding the length of the vector is just applying the distance formula. So if you remember, the distance formula is the square root of, we're going to have x2 minus x1 squared plus y2 minus y1 squared. And so in this case, remember when we're dealing with vectors, x2 minus x1 is just a. So this is going to be the square root of a squared plus y2 minus y1 is b. So square root of a squared plus b squared. So for example, find the magnitude of a, the vector v, which is equal to minus 2i plus 6j. So it's going to be so the magnitude, and the symbol that we use for magnitude is, and I should have put it up here too. So if this was our vector v, it looks a lot like an absolute value. Sometimes you'll see it just with 1. Sometimes you'll see it with 2. So I'm used to writing it with 2, but Alex does just write it with 1. So it's like a very long one that it writes it with. So we're looking at the magnitude of v, and the magnitude of v is going to be the square root of negative 2 squared plus 6 squared. So that's going to be the square root of 40. And you could just leave your answer as a square root of 40. Alex should take that answer. You could break it down if you want, but you don't need to. So let's look at another one. So what about if vector v is equal to minus 5j? So in this case, we could think of this as 0i minus 5j. So the length of v is going to be equal to the square root of 0 squared plus minus 5 squared. So it's going to be the square root of 25, which is just going to be 5. So the length of this vector in this case turns out just to be 5. All we're really doing is plugging in a and b into our formula here.